Two boats leave a dock at the same time. One boat travels south at 24 miles per hour and the other travels east at 10 miles per hour. Let me try to draw a picture of this. So I'm going to draw a vertical line and this time a horizontal line, and I'll say this point right there is the dock. This is where they will start. Okay, and my first boat is moving southbound at 24 miles per hour. So I'll say this orange line represents how my first boat is moving. It's gonna keep on going down that way. And I will have another line right here. Oopsies. I'll try to make this a little bit shorter because the orange boat, the southbound boat, is a little bit faster, right? 24 miles per hour. And then the eastbound one is going 10 miles per hour. So I'm saying this is east and this down here is south. Okay, so here's my boat that's going southbound. Here's my boat that's going eastbound. All right, it says after half an hour. All right, so if we give them half an hour, how much did this first boat move? It can move 24 miles per hour, right? But if you give them half an hour, this boat is at 12-mile point, right? Because it went half the distance it could cover in a whole hour. So I think I know this will be 12 miles. I'm gonna go ahead and write that. This is 12 miles because we gave them half an hour to travel. Next, how far this eastbound boat go? Well, it could move 10 miles per hour, but if you have half that time, this boat probably could go 5 miles in a half an hour. So I know how much the orange boat move and how much the green boat move. How fast is the distance between the boats increasing? That makes sense, right? Because the farther it goes, this first boat goes down south, the farther this other boat goes to the east, their distance from each other will get bigger, right? So let me go ahead and draw a dotted line connecting these two, and that dotted line represents the distance between the first boat and the second boat. Okay, and we're trying to find how fast is their distance, like distance from each other, increasing as they go their own way. Let x be the distance the eastbound boat has traveled. So I think I already know what x is. X is 5 miles. Okay, and y be the distance the southbound boat has traveled. I mean, if you give them half an hour, if you give them 30 minutes, that's going to be it. But if you give them more time, that's going to change, right? And z be the distance between the boat. Okay, so this will be z, this will be x, and this will be y. You know, I think I'm going to try to keep my picture general. So I'm going to go ahead and erase this 5 and 12 and just keep it as x, y, and z, okay? Because that 5 and 12 only applies for the case when we give them half an hour to be separated. Okay, if we give them hour or 2 hour or 3 hour, these 5 and 12 miles will change. So I'm just going to keep it as x, y, and z here. Okay, it says write an equation that relates x, y, and z. What kind of triangle did we just create? We have a right angle in the corner right there. This is a right triangle. So we can use the Pythagorean theorem. Okay, to write this equation that relates x, y, and z. X and y are the legs of this triangle, and z is the hypotenuse of this right triangle. So what we can say is if you square x and square y and add them together, that equals z squared. So this is a squared plus b squared equals c squared in terms of x, y, and z. But this is the equation that relates x, y, and z. This piece of information, I think I'm going to be using it later on. I'll say in 30 minutes. x is equal to 5 miles and y is equal to 12 miles. Because the first part was just asking for an equation that relates x, y, and z. I didn't really use this piece of information. X is 5 and y is 12, but I think it's going to come in the next part. It says differentiate both sides of the equation found in the previous step with respect to t. Okay, so that Pythagorean example or equation, x squared plus y squared equals z squared. Let's go ahead and differentiate this with respect to t. d dt both sides. Okay, so what's that going to be? X squared will turn into 2x times dx dt plus y squared will turn into 2y times dy dt. All right, what about the right hand side? That's just going to be 2z times dz dt. And that's it for this, okay? And then we have all these information that we can plug in now, right? We know what x and y is. And I think we can also even find z, okay? So let me try to find what z is, okay? That piece of information is where we need what we need at this point, okay? In 30 minutes, x is 5 miles and y is 12 miles. Using x squared plus y squared equals z squared, we can find what z is. So 5 squared plus 12 squared equals z squared. This will give us z is equal to, all right, let me see. We'll go ahead and do 5 squared plus 12 squared. And I'm going to take square root of I'm going to take square root of everything. So if you solve that equation, you get z is equal to 13. So we have these three so far. Look, we have x is 5. We have x is 5. We also have y is 12. And we also have z is 13. Okay, so we have, oh, I'm sorry, you could not see what I was circling. So we have these x, y, and z. But what other clues do we need? I think we need to solve for dz dt, right? They wanted to figure out how fast or how fast is the distance between the two boats increasing. So they wanted to see how fast z is increasing. But oh well, look, they gave us this dx dt and dy dt right here. So the speed that they gave us, that was a rate, wasn't it? So the first boat that was going southbound was moving at 24 miles per hour. So that's dy dt equals 24. Okay? And the eastbound boat going 10 miles per hour, that means dx dt, its speed is 10. So let's go ahead and use these two. Okay, these are the ones that we now need to put down. I'll put them down there, and we're just going to plug them in. Okay, so we have everything ready. We have everything to plug in. So let me go ahead and plug in. 2 times 5 times dx dt is 10, plus 2 times y is 12, and dy dt is 24. We're saying that is equal to 2 times 13 times dz dt. Okay, so if I solve that, I will be able to find how fast their distance is changing. So the first numbers, the left-hand side becomes 676, and the right side is at 26. Yep, 26 times dz dt. So if I want to find dz dt, I'll just go ahead and do 676 divided by 26. So dz dt, the distance between these two boats are increasing at 26. I have to go find the units. Miles per, I believe it was hours, right? Hours. All right, so that one was kind of difficult because we had three variables, x, y, and z, and all of them we had to differentiate with respect to time t. And then we had to plug in six different, one, two, three, four, five, actually five different numbers here and solve for dz dt. So the final answer, after an hour, the distance between the boats is increasing at 26 miles per hour. I think number 8 was definitely the hardest problem out of all the ones that we did. But I don't think I went over every single homework problem. So out of 12, I believe I went over about 8. So if you're trying other ones and if you want me to help you out on anything else, just write me an email about them, okay? So that's it for 3.9 related rates.